So let us look to secure user and application access. In securing application and user access, we have an architectural need from our beloved business, which is the cafe. The cafe needs to define what level of access users and system should have across cloud resources, and then they want to put these access controls into place across the AWS account. In this class, you will learn how to use IAM, which provides the feature that you need to meet these new business require. When you first create an AWS account, you begin with a root user account, and this user can log into AWS Management Console with the email address of yours, and also it will be associated with your credit card and billing information. The AWS account root user account has a full access to all resources, including billing information, personal data, and all resources that were created in any AWS service in that account. You can control the privileges of AWS account root user credentials. AWS is recommending you that you not to use AWS root account for day-to-day interaction with AWS. Instead, you need to create one or more IAM users. Keep the root user credentials in a secure location, which can make it more difficult for accessing the fully privileged root account user. So let us look now to an AWS Identity and Access Management service. It is a service that allows you to configure fine-grained access control to AWS resources. It will enable security best practices by allowing you to grant a unique security credentials to users and the groups. These credentials specify which AWS Service Application Programming Interface and the resources that they can use. IAM is secure by default. Users have no access to AWS resources until permissions are explicitly granted. IAM is integrated into most AWS services. Remember that the IAM service is global, so anything you do at the IAM level will be implemented across all AWS regions. You can use IAM to grant your employee and your application access to the management console or to the API using their existing identity system. So now just recently, AWS supports federation from corporate system like Microsoft Active Directory or standards-based identity provider. And these are very important for you guys to remember in the exam. IAM also support multi-factor authentication. If MFA enabled, the IAM user, once he attempts to log in, they will be prompted for an authentication code, and that authentication code is delivered to an AWS multi-factor authentication device. Those devices can be hardware, like an MFA device. They can also be virtual MFA devices that the user accesses through the application that runs in their smartphone, such as Google Authenticator. To better understand IAM, we need to understand the major components that we have in IAM. IAM user is a person or application that is defined in the AWS account, and that must make an API call to AWS products. IAM group is a collection of IAM user, and you can use IAM group to simplify how you specify and you manage permissions for multiple users. If you have a group of admin user, you can create the same permission and you assign that permission to the admin group, and that admin group, each member of that group will be inherited those permissions. The IAM policy is a document that defines permissions to determine what user can do and cannot do in the AWS account. IAM role is a tool for granting a temporary access to a specific AWS resources in an AWS account, and we will have more examples studying the IAM role and how we can use an EC2 profile to access a specific service via the role. In IAM, permissions are defined in IAM policy document. Those policies enable you to fine-tune privileges that are granted to principals. Those principals must be or could be IAM users, IAM roles, or other AWS services. When IAM check whether a permission is allowed, IAM first check for the existence of any application explicit denial policy. If there is no deny, they will check whether there is an explicit permission specified with allow policy. If there is no explicit allow policy exist, then the user will be denied by default. If there is an allow policy specified, then the user will be allowed to access the resources. You could also test those policies using the tool in AWS Management Console, which called IAM Policy Simulator. It is a useful tool for testing and troubleshooting an IAM policies. Remember, the policy in IAM are stored as a JavaScript object notation or JSON, and they are attached to principles as an identity-based policy or to resources as a resource-based policies. Identity-based policies are permission policies that you can attach to a principal or to identity, such as an IAM user, role, or a group. These policies control what action that identity can perform, on which resources, and under what conditions. So normally the IAM identity-based policy, we attach them to a user who wants to access a specific service, like for example, simple notification service. But if we have an S3 bucket and we want to allow public access to that S3 bucket, for example, we host our website there, so we want to grant read public access for anyone who wants to visit the website, then in this particular scenario, we want to grant a resource-based policy that you attach to S3 bucket. In this scenario, those policies control which actions a specified principal can perform on that resource and under what condition. Resource-based policies are inline policy. Inline means they are no managed resources-based policy. Here an example of IAM policy which is stored as a JSON document, and those identity-based policy are a document that you attach to a user or to a role. A resource-based policy are policy documents that you attach to a resource. The following are common elements found in the IAM policy document. We have the version, which specifies the version of the policy language that you want to use. And by the way, most students make a mistake by changing this version in the coming lab, but you need to keep it as it is. The statement, because this version is not the date of today, guys. This is a version for the interrupter that will interrupt the JSON object. The statement use the main policy element as a container for the following elements. The effect, whether it is allow or deny, to indicate whether the policy should specify an allow policy or a deny policy. The principle now, if you create a resource-based policy, you must indicate the account or the user or the federated user that you would like to allow or to deny access to. Now, if you are creating an IAM permission policy to attach to a user or to a role, you cannot include this statement. You don't need to have a principal because the principal is implied as that user or role. Now, in actions, you include a list of actions that the policy allows or denies. The resource now, if you create an IAM permission policy, you must specify a list of resources to which the actions apply. If you create a resource-based policy, this element is optional. And the condition now, you can specify a circumstances where the policy grants permission. For identity-based policy, guys, you must specify a list of resources that the actions apply to. The resource element specify the object or objects that the statement cover, and the statements must include either a resource or a not resource element. Most resources have a friendly name. However, the permissions policy language requires you to specify the resource or resources using the following Amazon resource name, ARN format. Each service has its own set of resources. Although you always use an ARN to specify a resource, the details of that ARN for a resource depend on the service and the resources. For information how to specify a resource, you could go back to the AWS documentation for the IAM service and the inline policy. You could also use for the action part a wildcard. You can use a wildcard character like star, which represent any combinations of 0 or more characters. So the action with a star here in SC3 star, this apply to all SC3 action. You can also use wildcard as part of the action name. For example, you can put IAM star access key, which will apply to all IAM actions that include the string access key, including create access key, delete access key, list access keys, and update access key. So the IAM policy documents are written in JSON. The Amazon DynamoDB table, whose name is represented by the table name, is going to be what the IAM policy grants user access to, and also the AWS accounts SC3 bucket, whose name is represented by the bucket name, and all objects that it contains. The IAM policy also includes an explicit deny, if you can see here in this example. The not resource element helps us to ensure that the user cannot use any other DynamoDB table or another SC3 actions or another SC3 bucket. So we want just to enforce them to use exactly the resources which are specified in the policy. This is the case even if permissions have been granted in another policy. An explicit deny statement takes precedence over allow statement. You can look to this activity, guys, in order to understand a few things, and we will leave it as an exercise for you so you can practice it later at your own time.